In this lesson, we're going to be looking at multiplying polynomials. First thing we'll look at is multiplying a polynomial by a monomial. So in this case, the single term here, the 3, is a monomial. X minus 1 is also a monomial. But x minus 1 we typically call a polynomial, and more specifically a binomial, usually. And this is a monomial. One term monomial, two terms binomial. So when we do this, this is a distribution. So we're going to multiply the 3 by the x, or multiply the 3 times the negative 1. And so we're going to get 3x minus 3 when we distribute here. And that's the technique that we use when we multiply a monomial times a polynomial distribution. The next example is similar, but just slightly more involved. 4 times 2x squared. That's going to give us 8x squared. 4 times a negative 3x is negative 12x. And the 4 times the 2 is a plus 8. And in this case, this polynomial is called a trinomial because the tri stands for 3 terms. The next one is just a little bit more complicated. Instead of just a number for the monomial out front, excuse me, we're going to multiply by a number times a variable, so the term is 2x. And the 2x times the 3x squared looks like this if we write it out. And the 2x times the 4x, and then the 2x times the negative 7, that's negative 14x. I've written out these because we also have to be careful here that we multiply the number times the number to get a 6, and the x times the x squared, which is x cubed. Remember, there's a hidden 1 on that x. Similarly, for 2x times 4x, we get 2 times 4, which is 8. And then x times x is x squared, because, again, each of these x's has a hidden 1. And then we have the minus 14x right here. And we're done. Let's go to the next page. So we can look at these products, these multiplications, another way, and this may be helpful to you. So the idea here is we can make a grid, you might say, to structure this distribution. And so we're going to put the 3 down here, off to the left, and we're going to break the x minus 1 into an x and a minus 1. And we go in an empty box here, and we're going to multiply the row and the column. 3 times x. And we're going to go to the next empty box, and we're going to multiply the 3 times the negative 1. And we'll get a minus 3. So we can see here that we get 3x minus 3. And that's what we did on the other page, but we did the distribution without this grid to structure us. And here's the next example that we already did. And again, we've broken this out with the monomial and the box off to the left. And we broke up the trinomial into 2x squared, negative 3x, and 2. And so again, we go and we look at the first empty box or cell, and we see we're going to multiply the 4 times the 2x squared, so we'll get 8x squared. We'll go to the next empty cell. 4 times negative 3x is negative 12x. And we'll go to the last empty cell, 4 times 2, which is 8. And we have 8x squared minus 12x plus 8. And that's our answer. Which is the same as on the other page. Let's go to the next page. And then, similar to the previous two, this is the same problem we did a few moments ago, just by straight distribution without this grid to support our work. In the first empty cell, it's going to be 2x times 3x squared. 2 times 3 is 6. X times x squared is x cubed. Remember, we add exponents when we multiply powers of x. 1 plus 2 is 3. 2x times 4x. 2 times 4 is 8. X to the first times x to the first is x squared. 2x times negative 7 is negative 14x. And we have our answer, 6x cubed plus 8x squared minus 14x right here. And we'll go to the next page. Now we're going to take this one step further now. We're going to multiply binomials. And we're going to be using a method that's called FOIL. FOIL is technically double distribution. FOIL stands for multiplying the first terms, the outer terms, the inner terms, and the last terms when we multiply binomials. So, for example, first terms are right here. Outer terms are here. Inner terms are here. And last terms are here. And so the word FOIL reminds us the order in which to multiply these in. So what I often like to do is this first terms, I will connect a line like that to the 1 and the 3. Those are the first terms, and so that's a 1 times 3. Outer, I'll go push out to the outer terms, the 1 times 4. The inner is the 2 times the 3. And the last is the 2 times the 4. And so this simplifies. We'll get 4 plus 4 plus 6 plus 8. That's 4 plus 4 is 8, plus 6 is 14, plus 8 is 22. And we can notice here that I made a mistake, didn't I? What was my mistake? Let's see. It should be 21. 1 times 3 is not 4, it's 3. So this answer is in fact 21. Okay, even math teachers make mistakes. And here we could just check our work. 1 and 2 is 3. 3 plus 4 is 7. 3 times 7 is 21. We're good. So that's a quick look at FOIL where we're just looking at numbers. We're going to go to more complicated looking binomials now. Oh, and we could of course do this method again here. In this case where the first part is 1 plus 2, and the second part is 3 plus 4, we can put the 3 and the 4 here, and we can put the 1 and the 2 here. But the game is the same. We go into this empty cell here, and we go 3 times 1 is 3. We go over here, and we see it's 3 times 2, which is 6. We go over here, it's 4 times 1, it's 4. And we go over here, it's 4 times 2 is 8. And so we see that we have 3 plus 6 plus 4 plus 8. The order that we add these in does not matter. And we should get 27. 9 plus 4 is 13 plus 8. 27, 21. Maybe we're going to get to the more complicated ones now. Yes, we are. Here we go. So more typically in algebra, we're going to be working with variables too. And so our binomials are going to be terms with a variable, typically, in each one. So x plus 1 times x plus 1 is also known as x plus 1 squared, if we were to write it that way. And we're going to use FOIL. So first terms, x times x. Outer terms, x times 1. Inner terms, 1 times x. Last terms, 1 times 1. Simplify. X squared plus x plus x plus 1. This is x squared. X plus x is 2x plus 1. We can break it up into x and the 1 and the x and the 1 as before with this grid. And in the first cell we have x times x, it's x squared. This cell it's x times 1, which is x. In this cell it's 1 times x, which is x. And in this cell it's 1 times 1, which is 1. So we see we have x squared plus x plus 1, which is x squared plus 2x plus 1. Same answer as we got above. Again, this grid structure, it's sort of like a table with empty cells, allows us to structure this FOIL calculation in a visual way. Use that method if it helps you to do these problems. Now here's x plus 1 times x minus 1. So we're going to use FOIL. And the first terms will give us x times x. The outer will give us x times a negative 1. The inner will give us a 1 times x. And the last will give us a 1 times a negative 1. And when we simplify, we're going to get x squared minus x plus x minus 1. And this is interesting. These cancel. Negative x plus x is 0. And we're left with x squared minus 1. A binomial. Similarly, we can break this into our grid or table with the empty cells and set up the x minus 1 and the x plus 1. And we can go into the empty cell here and we see we have x to the first times x to the first, so that's x squared. We go over here, it's x times 1 and we get x. Over here we see it's negative 1 times x, which is negative x. And then here we see negative 1 times 1, which is negative 1. And when we bring this together, we see we'll have an x squared plus an x minus a 1. Again, these x terms are opposites. They go away, they cancel, and we're left with x squared minus 1 again, the same answer that we got before. Well, the previous problem was kind of interesting because we had this x plus 1 times an x minus 1. And we wound up getting this answer here, x squared minus 1. It turns out this is a special form here. And when we see x plus something and x minus something, and it's the same thing here, it's the same thing here, we simply take the first part and we square it, and then we subtract the second part and we square it. And that leads to this, because x squared minus 1 squared is x squared minus 1. This is a special form right here, and it can be written as this more generally. A plus b times a minus b is equal to, well, the first part squared minus the second part squared. And we'll probably see that again this year. Very useful form in algebra. Here's another example. And we're just going to go ahead and FOIL this one. So first terms, x times x. Outer terms, x times 4. I like to say 4 times x, 4x. Inner terms, 1 times x, which is x, and then 1 times 4, which is 4. And so this is x squared, and 4x and 1x is 5x, and then the 4, and there's our answer. Again, I'm going to skip this the grid approach, which also works fine, as it has before. Now we'll come to a still slightly more complicated example here. We've got 3x plus 2 times 2x minus 5. And when we FOIL, we'll go 3x times 2x And I'll write this out. If you're comfortable with this, you don't have to write this out. Outer terms, 3x times negative 5. I'll go with the number first, negative 5 times 3x, and then 2 times 2x, the inner terms, and then 2 times negative 5, the last terms. And 3x times 2x is 6x squared. Negative 5 times 3x is negative 15x. 2 times 2x is 4x. 2 times negative 5 is minus 10. And then when we simplify, we can bring those x terms together. We get 6x squared minus 11x minus 10. You'll notice the order we put these polynomials in: highest degree, to lowest degree, as we go left to right. And remember, the degree of a monomial or a polynomial is determined by the exponent. So x squared, that's degree 2. X, if we had an x to the third, it would be degree 3, and so forth. Again, this example could be done with the table here. So 2x times 3x, 6x squared. 2 times 3 is 6, x times x is x squared. Here we have a 2x times 2, which is a 4x. Down here we've got a negative 5 times 3x, which is a negative 15x. Over here we have a negative 5 times 2, which is negative 10. And so we get 6x squared plus 4x minus 15x minus 10. And then again, 4x minus 15x is negative 11x. And again, we have the same result that we got above up here. And I think we'll stop our lesson at that point. And you guys will have some practice work on this that I think that you will be ready for now.